This talk is on statistical graphics in Clojure and specifically ClojureScript on the internet. That's kind of a niche topic. Really what this talk is about is the power of visual displays of information. Pictures, I think, are compelling in a way that text is not. And not just in an aesthetic sense in terms of rounded corners or drop shadows or something, but sort of more fundamentally, there are certain kinds of problems that are very difficult to understand or comprehend in traditional displays of text or as a table of numbers. But when you make a chart or a visual depiction, they become very simple or intuitive or obvious. And so I think when we make our software, we're very biased towards using just text. And if we leave out the visual dimension, I think our software is really incomplete or crippled, and we're keeping our users from being able to explore fully different kinds of problems. And so for this talk, what I'm hoping is that I can give you not only just an appreciation of different kinds of visual methods of communication and displaying information, but also concrete steps that you can use in Clojure on the internet to actually make more visual interfaces and make data sets sort of more intuitive and interactive on the web. Okay, so the agenda for the talk is in two parts. The first part, I'm going to talk briefly about information design and why I think we as programmers are terrible at it. I think partially this is because we don't really think about it, but even if we do, the tooling is just really terrible. So even if we have an idea for a really interesting or good visual representation of some data set or a problem or a program, a lot of the time we have to fight sort of tooth and nail with our tools to make that happen. And so I think doing the right thing should be easy. And so for the second part of the talk, I'm going to discuss about, in practice, at least one way you can go about using ClojureScript on the internet to make visual, sort of data-driven interfaces. Okay? And I think the talk is going to be about 20 minutes long, so that'll leave 5 minutes for questions at the end. All right, so part one, information design. There's a lot of stuff that's been written about this topic, but I thought the easiest thing, for this talk would be to just dive straight into an example. And this is hopefully something that will be in your recent memory or something that's familiar to you. My guess is that not all of you live in San Jose, and so you had to actually fly out to this conference to be here. And so you had this really concrete problem. You needed to find some information. You needed to get like flight times and prices and stuff like that. And so if you're anything like me, you wanted to solve this problem, and you got on your computer, and so you asked your computer for this information, and odds are your computer drew you a picture like this. Okay, so this is a screenshot from Orbitz. A standard sort of results screen, nothing to write home about. You type in your query, gives you a page like this, it's showing you just a list of the results. So you can see just above the fold there are two different rows showing different flights. And if you look really closely, it says the departure and arrival times and all this kind of stuff. And this is just totally typical, right? This is a standard fare in our industry on the internet for so many different kinds of problems. And it's a sort of thing that you just don't think about really the design that's into it or the decisions that are made. And it takes something from sort of out of the blue or out of left field to really get you to even notice that this is a certain kind of problem. So I don't know how many of you have seen this interface. This is a screenshot for the results page of a startup called Hipmunk. It's the exact same problem. So this is just a visual representation of flights for the same search. So these are flights from Portland to San Jose. And I'll just break it down what's going on here. Each flight is represented by a rectangle, and they're all sorted. So they're sorted vertically by the price of the flight, and then they're sorted horizontally by the departure time of the flight. So flights that leave early in the morning are on the left side of the screen, and then flights that leave later in the day are on the right side of the screen. And the actual width of the rectangle is the duration of the flight. And so you can see sort of immediately in this visual representation so much more information, and it's just fascinating to me because this is the exact same data that was on the other screen. You could take this screen and some colored pencils and a ruler, and you could make this. But this this representation is just, in my mind, is clearly superior because it lets you do so many more things. Like, it's very easy to just immediately see what's going on. You can make comparisons very easily, so you can see just immediately that the cheapest flight is going to be sometime in the afternoon, right? And then the next most expensive flight looks to be really early in the morning. And then as you're looking down, you can actually see this blue bar at the bottom is the train. And so you can see that if I wanted to take the train from Portland to San Jose, it's going to take me 8 or 9 times as long as taking a plane. And all this stuff just sort of jumps out at you. Whereas on this sort of standard screen, you actually have to read this text, and you're going to scroll up and down and juggle all these numbers in your head. And so what really baffles me is that, this is, I think, just a great representation, and it's a great picture of that data. And what I find baffling is that it took something like 10 years for people to come up with this, right? And why is that? Because it's not like some technological breakthrough, right? Because in 1997, Priceline.com had the technology to draw rectangles on the screen, right? I think the reason it took so long for this to happen is because it's a real sort of mindset thing, where no one even knew that this was a problem, right? Like, if you think about programmers, what you do as a programmer is you spend all day long looking at code, right? You're looking at text. And so if you are faced with this problem of presenting information to the user, odds are you're going to reach for what's easy and what's nearby, and what's built into every single programming language. You're going to reach for this guy, right? And you're going to write a program that looks like this. You're just going to say, oh, I have these flights from the database. I'm going to loop over them, and I'm going to print them out to the screen. And then the poor user is going to end up with an interface like this, right? And yeah, technically, you showed them the information. The data is all there, but it's not really in the most usable or intuitive form. And all of us have written this program, and what I'm hoping sort of for the rest of the talk is that we can move on, and actually I'm hoping to be able to give you an idea about how you could write a similar kind of program that's going to give you a picture like this. And so what I'm hoping for the rest of the talk is that you can sort of keep in mind your own work and the problems that you're working on with your own software, and think about possible visual representations that you could use to display data or to let your user interface with your program and your data in a visual way. Okay, so that's part 2 of the talk, which is making pictures of data. There are a lot of different ways to do this, right? I mean, you guys are all familiar with bar charts and line charts and pie charts and maps and stuff. And really what all of these pictures have in common, what fundamentally makes up a statistical graphic, is that what you're doing is you're mapping visual elements to the underlying data. So for instance, on a bar chart, you have some collection of numbers, that's your data, and what you're saying is you're going to make this mapping. You're going to say, okay, for each number, there's going to be a rectangle, and the width of that rectangle is going to be given by the magnitude of the data, right? So that's a bar chart. Same thing with something like a scatter plot. You have a collection of tuples, and you're going to say, for each tuple, I want to draw a circle, and I want to position, the circle over to the left and then up based on the magnitudes of the different dimensions of the tuple. So you're probably wondering, okay, well, that's great. How do you go about doing this kind of thing on the internet? Well, luckily, some really smart people down at Stanford were thinking about this problem, and last year they released a project called D3. So this is from Mike Bostock, who I think is now at Square, and his sort of colleagues. And D3, it stands for Data-Driven Documents, and you can kind of think of it as jQuery on data. So their insight was, hey, we have this great drawing tool. We have all these great tools and ecosystems on the web with like HTML and CSS and SVG and stuff. So why don't we make a framework that makes it really easy to do this mapping, to make statistical graphics, so to take data and to make elements on the DOM, right? So the basic idea, right, it's in JavaScript, it's this library, and you say, here's my data, and you tell D3, okay, for each datum, I want you to make a div, and I want you to map the attributes of that element in a certain way. So in this case, if you wanted to make a bar chart, you would say, for each number, make me a div, and then map the width attribute of that div to be, the number plus the string px for pixels. And then that's how you could get a really simple bar chart. So this is really awesome. This is a really just it's one of those ideas, at least to me, that it just seems so obvious when it's explained to you, but it's just really, really powerful. It's great for a couple of reasons. One is that it's just declarative, right? So you don't have to think about looping or sort of trolling around the DOM yourself. You just tell the library, this is my data, this is what the representation that I want in terms of the DOM element and its attributes, and it'll handle all of that for you. And the other great thing about it is that it's a familiar representation, right? It's not some custom scene graph or a new language that you have to learn. It's all the kinds of things that you as a web developer would be familiar with already. So you already know HTML, you already know CSS, you already have your standard sort of development tools. So if you're making a visualization in D3 on the web, you can just open up the Chrome debugger and poke around with that and mess around on the JavaScript console. You don't have to use some totally new tool chain or anything. So there's no reinvented wheels. So D3 is a great library. I've been using it since it came out last year to make a lot of different interfaces on the web and visualizations and stuff like that. And when ClojureScript came out last summer, I sort of thought, well, wouldn't it be even awesomer to take the strengths of Clojure and ClojureScript and use the same idea? So, Clojure has much richer data structures than JavaScript, and it has a very deliberate model for handling state and identity. And it has some, a lot of syntactic niceties in terms of destructuring and stuff like that. And then things like namespaces, which end up being really important and helpful to build larger, more complex applications. And so, I was kind of sitting on this idea for a while, and then over the course of a couple client projects, I ended up building out a D3-like library in ClojureScript, which we open sourced about an hour ago. So you can find it here. We've imaginatively named it C2 because it's D3, but in Clojure and less complicated. And so for the rest of the talk, I'm actually just going to walk through an example of this idea and then how you would use C2 to make a data-driven graphic and interface on the web. Okay? All right. So let's say, hypothetically, that you have a Clojure collection of data representing flights. So this is just a vector of maps, right? And each map has keys like the flight ID number and the price and the airline carrier and the departure and arrival time and stuff. And let's say you want to make an interface like Hipmunk, right? You want to make just this nice visual representation of all this flight data. So where do you start for something like this? There are a couple different ways that you can break it down. When I look at this graphic, I kind of see that, okay, for each flight, we're going to want to have a row. So let's make a div element to be this row. And then inside that row, it looks like we want to have a button that's going to have the price of the flight in it. And then we actually want to have a little rectangle to represent the flight itself. So let's just make another div there. And then, we want to style that rectangle. So we're going to want to say, okay, it needs to be over to the left according to the departure time of the flight. So let's add that as the left style attribute of that div. And then, as a quick interlude here, notice this timescale function. That's just a really simple linear function that's going to map from the domain of the data to something that CSS understands. So in this case, we're saying, okay, the flight is going to depart somewhere between 0 and 24 hours, and we want the range to be something between 0 and 100%, so we can actually position the element inside the parent div. Okay, so that's the timescale function, and we want the flight to be as wide as the duration of the flight itself. So that's just the timescale of the arrival time minus the departure time to get the duration. And then inside the flight, we actually want to have a little text that has the name of the carrier in there. So we can just add a little span child there. And then one final thing, in this graphic, it looks like we want to have the flights be colored differently by the airline. So Alaska Airlines is this nice reddish color and United Airlines is blue. So let's just add the airline carrier as an attribute on that div. And so then in CSS, we can just make a selector that says, when carrier equals Alaska, background color equals red or whatever. Okay, so this is all we need. That's basically the representation for the flights. We're going to need to do this for each flight. So if it's this repeatable thing, we might as well make it into a function. So let's just make this an anonymous function here. And then notice the arguments to this function, we're going to get the data and then the index of the data. And then since we know that the datum, an individual datum is a map, so we can use Clojure's destructuring functionality here to just say, let's pull out the keys of this map that we're interested in and make them into locals. So we're just going to pick out the price and carrier and departure and arrival times as local variables. So what we have here is a function that takes a datum and it returns a vector representing the DOM. And so if you guys have used Hiccup, the Clojure HTML library, this is the exact same kind of thing where we're representing DOM elements using just a vector, and we're representing their attributes using a map. Okay, so we have this anonymous function here, and so we're actually going to need to apply it in ClojureScript. So we're going to call this unify function. So this is the one function that you use in the C2 library pretty much, and what it takes is a CSS selector for the container, and then the data, and then this anonymous function that's going to map the data to DOM nodes inside that container, right? So in this case, we're saying, all right, here's my chart, here's the flight data, here's this function, make me my graphic. And when you do that, this is actually what you get. So there's some CSS trimmings on here that's adding the color and the zebra striping on the table and stuff, but this is all you need to do to make a graphic like this. So already it's nice because Clojure is so sort of succinct, and the data structures are so rich that you can do all of this in something like 10 lines, make a graphic that looks very much like Hipmunk. Of course, we're going to need some axes on here, so we can play the same kind of game and just say, here's a collection of numbers. For each number, let's make a div and a grid line with a label and stuff like that. So that gives us the axes. And again, this is all just standard Clojure stuff. There's no real fancy, closed, behind-the-scenes stuff going on in here. And so you can really get as complicated as you want when you're making graphics like this. So you could say, I don't really like these labels here. It'd be nice if there were like human readable labels or something. So if you wanted to do that, you could just get more complicated. You could say, as your data set in this case, I'll give it a set of tuples, right, where there's the actual time and then there's a human readable string. So you can say, 12 is the time, but you actually want the label to say noon or whatever. And so you can just get as fancy as you want and in making representations like this, and it all sort of comes along for the ride. So that's like pretty great, right? I mean, Clojure has so much stuff baked into it that you can do a lot of advanced stuff pretty easily. So that's nice. The other thing that's great about Clojure and ClojureScript is that there's a very deliberate model for handling state and identity. And C2 actually takes advantage of this model by doing some clever stuff when you pass it an atom. So in ClojureScript, the only reference type that's implemented right now, I believe, is atoms, which is just an object that's going to point at a value. And so you can have the atom point at something else, and so you're effectively changing what it's pointing to. And if you give C2 an atom in a data set, it'll be smart enough to sort of watch that and say, oh, this data set has changed. I better update the DOM to follow that. And so all of this sort of happens behind the scenes automatically for you, and you can do some nice things with it. So for example, in our interface here, we can implement sorting really easily, but by taking advantage of this fact. So the first two lines here, I'm just adding 4 different buttons to the top, and then the next 2 lines, I'm adding an event handler on those buttons that effectively says, button, when you get clicked, I want you to swap out the current value of the flight data atom with an updated value given by this function that's going to sort the flights by whatever field was clicked on. And so in the same 4 lines of code, you just add this on here, and then your page, you actually get this nice kind of functionality all sort of for free because of this declarative syntax and Clojure's sort of baked-in handling of all this stuff. And one thing to notice here, C2 is not recreating DOM elements. It's not making a whole new sort of inner HTML and replacing the old stuff, but it's actually walking the existing DOM and updating the appropriate attributes and adding and removing children as necessary to make everything match up. And so because it's walking the existing DOM, you can take advantage of things like CSS transitions. So If you notice these blue flights, when I click this little button at the bottom right, it's effectively delaying all the Pan Am flights. And so when that happens, CT will go in and it'll update the attributes. But because in CSS I have said use WebKit transition all 1 second, that's effectively telling the browser when the style gets updated, don't immediately update it, but spend a second interpolating from the old value to the new value. And so you can use this to sort of get animation for free. Like there's no animation code in this library, but there's a lot of animation code inside the browser that's very efficient, and so you can just sort of leverage all of that. And this is sort of doubly important if you do mobile development. So we've done a couple projects in ClojureScript targeting the iPad, and you end up having to use CSS because it's hardware accelerated, so the animations are a lot smoother and faster than if you tried to do them yourself by just updating the value very quickly in JavaScript. Okay, so that's really nice. And another thing nice about Clojure and ClojureScript is this deliberate state model where you can just, again, declaratively say, this is the representation that I want from my data on the DOM, and then you can update it, and then it'll sort of automatically get updated by following all of the state. So that's pretty much it. That's all I have time really to talk about now. 20 minutes is a little fast, but I'm hoping that over this time, I said that I hope to sort of convey a sense of the power of visual communication. And so I hope that by walking through this one example, you have ideas in your own head about the data that you use and the software that you're building, and maybe you have some ideas not only about what would be nice to make, but you actually have sort of concrete steps to go forward about how you could implement them in ClojureScript on the web. Okay, so thanks.